Hello everyone, my name is Vladimir Gordeev, and today I want to talk about efficient development tools and how we can create such tools that would be really convenient for humans. And I want to start with a question. So in the past, people created programs in machine language. It meant that people calculated on paper integers that would make machine behave a certain way, put it together, insert into machine, and it calculated things. Then someone invented assembly language. It wasn't faster, but it was more convenient for humans. It was more efficient in terms of human time. Then someone makes a step further and create a high-level programming language. That's the Fortran high-level programming language. And it was more flexible, more expensive, and also machine independent. And seeing this progression, my question is, what's going to be next? How are we going to program in the future in such a way that would be more efficient than writing text in high-level programming language that is machine independent? And if you follow me through this presentation, probably you will maybe get some ideas how it may look like. And that's the plan of the presentation. First, I want to show the problem. Also, later I would like to demonstrate with examples where I see this problem when it appears, how it might be solved. Later, I would like to share the vision of really efficient, convenient development tool. Then I will show some existing projects that try to move in that direction. And at the end, I will explain what I'm doing now, what I'm trying to achieve. So the problem. Many companies face with problems when their software doesn't perform as good as they want. And they have two choices: either add more hardware, more memory, more CPUs, or optimize program. And usually people just add hardware because human time is expensive. And machine time, it's cheaper. And I see the problem as human time is more valuable, yet it's not that optimized. We have visible progress when it comes to machine, better CPUs, more memory, faster. When it comes to human time, it's not that visible. Maybe there is a progress, but it's not that obvious. And yeah, we have various techniques to make machine work faster, make program work faster. We can reorder the values in memory. We can reorder the instructions. That's compile scheduling. We can do some additional optimization inside the CPU. But what we're going to do for brain? Because brain is still one of the most complicated things in the world. We still don't know how it works, and it's really hard to think about optimization for brain. We can describe on the left. You see two diagrams. On the left, you can see how we can think about program execution. We receive instruction, data. We compute. We calculate the instructions on CPU, and then we output data. And we can think about process of programming a similar thing. You learn about the problem. You receive description of the problem, maybe expressed in natural language. You have your brain yourself that thinks about the problem, solves it, and then you output it. In terms of source code, comment on terminal, maybe some clicks, that's your output. That's your solution to the problem. And we can optimize for machine by changing the format of instructions, like reordering them, that compile scheduling. Or we can reorder the data, that's memory alignment. Or we can go inside CPU and add pipelining or branch prediction. And we think in similar terms about brain, about humans, about programming, what we could do. We could change the description of the problem. That would mean that we should provide a task to solve in really strict language, specification. That would be easier to program. Another alternative is to hack the brain, add some power, but it's not possible yet, it's sci-fi. And the last is to change the format of output. Change the user interface, change the syntax of programming language, change the abstractions of programming language. The output that humans need to produce to provide solution. And when it comes to optimization for human-computer interaction, there's a lot of empirical data, and there are some expertise. For example, Jeff Raskin, he's original designer of Apple Macintosh, and he wrote a wonderful book called The Humane Interface, where he lays down the theory how the brain works and how we perceive and how we could design interface in such a way that it would take into account human limitations, how we form habits, how it works. And there are some really good principles from this book. I just want to take 2 of them and provide examples when they're violated, when they're respected. And I want to show it on an example of programming languages. Yes. For example, probably you already see this comic. Is the #1 programming excuse for not doing anything. My code is compiling, and some programmers fighting on swords on office chairs. If compilation is really slow, you indeed cannot proceed working. You need to wait until your code compiles. And there is a really efficient cycle, a state flow that you enter when you work on the problem. And one of the Raskin principles is that concentration should not be interrupted as long as possible. And if your compilation is slow, it means that if you want to try to change something, experiment something, change the code, see what happens, you need to wait a really long time until your compilation finish. And for example, in some projects, for example, in game engines that are written in C++, compilation may last like 30 minutes, sometimes more. But also for some programming languages, it's not a problem. And it turns out that it's not really a problem of compiler quality, it's a problem of the programming language design, how its model system is designed, how dependencies are, how code depends on each other. And often it's possible to parallelize it and compile independently. For example, in Go programming language, you don't have this problem. They thought about it and designed it. So they don't have this. When you program in Go, you don't have this problem of losing concentration. Yes, slow compilation. Another reason for losing concentration is inconvenient input reproduction. If your program just takes in file, returns file, that's easy. You have one file, you run it over, it's easy to reproduce. But if you create some multi-microservice system where you have several different applications that communicate with each other, and you have a problem, bug, that appears in production and you need to reproduce it. It's really complicated. You need to start this cluster locally on your computer, or you have to debug it in production. Both ways are bad. And also slow. You cannot do experimentation really quickly. You have to lose this concentration, get out of this fast cycle. Yes, there is a partial solution. It's not always convenient, but there is a good project developed by Mozilla, Record and Replay. They allow to record the execution of some programs. For now, as far as I understand, works only for C, C++, only for single-threaded. But it allows you to record execution, take it to your computer, and replay it, and see all memories, all memory, how it changes. You can understand where the problem. Yes, another problem is inconvenient navigation to library source and documentation. When you try to solve the problem, you traverse the code. And if you see that there are some components that you don't know what they do, you don't know what kind of effect they may have, you have to dive inside and understand what's happening. In some IDEs, it's a solved problem. For example, for Java programming language, sometimes you just can click on the method, you can jump to the source code of this method, and it's really convenient. But this feature forces you to configure IDE in such a way that it would know how you compile your project, because you may have several versions of the same library. Which one to take? You need to tell IDE to do that. And even worse, for some programming languages, it's just not possible to implement. For example, here we have a little example in Python. We create object that is just empty function that does nothing. We dynamically add method. And then we call code, and here we use this method. So when you work in IDE, when you're trying to understand what M1 does, it's not possible. It's not possible because the code that would be executed when you call M1 is defined at runtime. It may change. It's just variable. So sometime of the execution, it may do one thing, then variable would be reassigned. It would do completely other thing. And it really complicates the understanding of the code. It really, you cannot be in this fast cycle when you can quickly experiment and quickly understand what's happening. Another example. This is a really simple program in C. What do you think it does? Well, printf does printing, so it takes format string, which tells it to print number, just 15. So basically, it should print 15. That's it. That's the whole problem. But it's a C language, and we have this library. Let's take a look what's inside the library. There might be a macro that redefines printf. So you see this code, you think it's going to print, you develop this habit, but language is designed in such a way that you cannot rely on this habit. It may do something totally different. You cannot trust things what you see. And it's also an issue of programming language design. And in some languages, it's not an issue. For example, in Erlang language, macro and function call are two different things. They're visually different. So you can develop this habit, and when you see a function call, you can trust that's a function call. That's the principle of capitalizing habit. So design tools in such a way so that user could rely on habit that they develop. Yes, that's the summary, 2 principles that I covered up. Another thing is I stumbled upon lectures of psychology professor that works with patients and works with such topics as depression and meaning in life. And in his book, Maps of Meaning, he lists some principles that I found really interesting and applicable for programming language design. It sounds strange, but I genuinely believe so. So, that's the 3 principles. Is world is perceived as a composition of order and chaos. That's how humans seems to see it. And the other 2 is the most comfortable position to be is on the edge between order and chaos. And most comfortable when order and chaos are balanced. It sounds too abstract, and far-fetched. So I would provide an example so you would see what it means and how it could be applied for programming language design. Yeah, so what is the order versus the chaos according to Jordan Peterson? Order is explore territory, something predictable, certain, safe, but also rigid, because there are strict rules and you cannot do what you want, you are limited by a system. Chaos is the opposite. It's unexplored, unpredictable, unsafe, yet it's also flexible, because anything is possible, or at least something is possible that you don't see. So, for example, you have a web server, and it receives requests, and something went wrong, and it doesn't work correctly. And here we have a diagram that depicts the execution path. So time flows from left to right, and horizontally you have different positions in code. So when you execute, you just jump from one function to another, and you proceed like this. So this is the execution path. It goes like that. And when something doesn't work correctly, you insert print statements or you set a breakup in the middle to see what's happening. So we'll put the breakpoint here. And if all variables are the way they should be, if everything is predictable, behaves correctly, it means that this path before the breakpoint is in order. You feel safe about it. But program still doesn't work correctly. So the problem must be up front, here. And this is the unpredictable part. You thought you know how it works, but turns out you don't. There's something that you don't know. And you're right on the edge between order and chaos. And according to Jordan Peterson, it should be the most convenient place to be. And how we work with this problem? We go deeper and deeper until we find a problem. We set breakpoint here, go deeper, and eventually, it's an iterative process. We're going to find a problem, we're going to fix it. But imagine for a moment that somewhere in this area where code executes, some code uses global variables. It means that it may accumulate some state between your iterations. So you provide the input, you run it again, provide the input, you run it again, because it's bugging. And global variable may accumulate something and influence the code. And it would behave differently. So you thought you know how it works, you thought you know how it behaves, but turns out it's unpredictable because it's influenced by a global variable that is not under your control. And so you got both before and after parts unpredictable. And you're in this state that you don't want to be. And so in this way, global variables as a feature are shifting balance towards chaos, shifting this experience of programming towards chaos. Yeah. And we can think about this as global variables as a feature of programming language, and they shift balance towards chaos. So there might be more features that shift in different poles. And it seems like those features, static typing, immutable data, pure functions, shifting towards order, while the other features, like dynamic typing, mutable data, metaprogramming, that's a big one, shift towards chaos. Metaprogramming allows you to generate programs during the execution of the program and execute them. So you can write programs that write programs that write programs. It's self-modifying programs. Really powerful, really uncertain, really hard to debug. And if we have these features, we have this shift on the balance, there must be languages that are really shifted towards order or really shifted towards chaos. And what is this language that shifted towards order, static typing, immutable data, pure functions, no dynamic code loading? Maybe I believe that may be Haskell, because that's what pops up. It's really safe, really predictable, but also rigid, because it takes a month to learn how to do input-output. Another example, what is this language that shifted towards chaos? So it's dynamically typed. It has mutable variables. It has metaprogramming. It can load code during the execution. I believe that Lisp fits this description. It's really flexible, but also really unsafe. It's hard to debug. Yes. Right now I want to try to explain the vision of this really convenient tool that I would like to have. So immediate navigation to code and docs, that you wouldn't lose this concentration, you would continue to stay in this flow. Execution replay. Actually, it's not that hard to do if your code is deterministic. So you can record external inputs, and all execution that follows after that is deterministic, so you can repeat it many times. And, yes. Time trial debugging. This way you wouldn't even need to reproduce the input. You just could go back in your debugger. Like not only forward, but back. And last one might be really convenient, is that sometimes in your project, some of the parts are described in DSLs, domain-specific languages. For example, if you describe database schema, you define table, relationships, how they depend on each other. We already use special languages for this. For example, in Ruby on Rails, you have really special DSL. It might be more convenient to go further and parts of the program, not all, but parts of the program, make available as visual DSL, visual interface that you can manipulate with. Yes, existing projects. So this is the Lighttable. It's IDE for Clojure programming language, and you can see that they did interesting thing with navigation. So you can immediately jump from current function to do any other function that's used in this function. You don't have to jump between files or scroll it really quickly. You don't have to lose concentration, get out of this loop. You can navigate really quickly. Another example, Smalltalk, they also provide that kind of navigation. Well, yeah, similar to this. It's also interesting that Smalltalk code is not stored in files, it's stored in database. And that's probably why it's easier to implement. Another example is Dart language. It's not publicly available yet, it's in private beta. For example, those windows that you see here, they are HTTP handlers. So on the title you see the route, and the content is the code that processes requests. And they also they record the requests to each route, so you can easily reproduce the input. So if you had, say, 5 requests before and you change the code, you can see how they would be processed now. And the last one is Elm language. They implemented the time trial debugger. Of course, it's limited. It's not always possible to use, but still it's a good example of movement in that direction. And when you work with data, when you develop IDE or programming language, it's just a program. You work with data, and this data is code. And when you develop IDE, you constantly jump between two representations. Text representation that people use, that they type in their editors, and tree representation that IDEs use inside when they provide all those wonderful features. And there's an idea, it's called structure editing, is that we could design IDEs and programming languages in such a way that code is always a tree. It's not stored in text. You edit a tree. And there are interesting things because of this change. For example, you don't have to have name clashes, because in traditional text languages, name of the function and identifier of the function is the same thing. But in structured editors, name is for humans to read, but ID is for machine. And you can have several functions with same name, just like you can have several people with same name in Facebook. It's a different kind of storage, and it provides some enrichment. Also, it provides more features when it comes to versioning. It's more fine-grained. You can get more information from it. And there are actually structured editors that do exist, and it's not it's an old idea. For example, here you have subtext programming language developed by Jonathan Edwards. I'm just trying to show that they actually do exist. This is the Envision programming language by Dimitar Asenov. And the last one is Lambda language. It's a functional programming language developed by Lambda team. So you edit directly tree, not text. Even though it looks like text because we're used to it, but inside, down there, it's a tree. And those screenshots that I showed, they didn't look really sexy. It might be that they are not that convenient to use yet. And I believe that happens because of the following. When you create a structured editor, you have to design two things: programming language and programming environment. And you design them at the same time. You have to connect them tightly. Yeah, and probably that's the main challenge. Almost done. And what I'm trying to do is to avoid this trap, to design programming environment, and only then, after many attempts, try to design programming language. So idea is that to use directed acyclic graph as a universal data structure for code, for data, for many other things, provide really generic tree editor, so it is not connected to any programming language. Just like now, we can write code for any language in any text editor. It's not tightly connected. You don't have Python text editor or Java text editor. You can have one text editor for any programming language. I would like to have the same for structured editors. And after having that, I would like to have an API so we could develop additional user interface on top of it. And this is how you can see the difference. That's how structured editors design now. You have storage, programming language, runtime, and widgets. They're closely coupled. And what I'm trying to do is create an editor that has one storage, but probably many different user interfaces, many different languages that use the same storage. And that's a screenshot of my prototype. It can edit trees. You can navigate with childs. You can jump. Yeah. And in the beginning, I asked this question. So what is this new way of programming that would be more efficient for humans? And I believe that would be structured editing. It may not look really great right now, but it seems like there might be no other way to make human time more efficient. Yes, I want to say thanks to Professor Matara for support and to Steve Krause for organizing Future of Programming community, where you can find people that think about these problems, about IDEs and programming languages. Thank you. And I would be glad to answer your questions.
I am very glad you presented not only the idea that is interesting, the content itself, but also your presentation is professional, the style very professional. You drink very often because you are tense, but this is the only thing that distinguishes between you and the professional speaker, because your presentation was very professional.
Thank you.
Okay, anyone want to say anything? I'm sure that he woke up when you mentioned ASCII, he woke up.
Okay, yeah. Thank you for the presentation. Really interesting that you have this survey of different things are done in this design space. Have you heard of the Luna language?
Yes, I did. And actually I had a slide about it, but I tried to condense it, so I removed it.
Okay, because I think so some of the interfaces that you showed are maybe outdated or they were an attempt.
Yes.
For some reason, I think Luna language, right? Well, the recent things that I've heard of it is that it is actually in some specific niche. It is very successful, and they have very cool demos at least.
Yeah, I've seen that.
So okay, just wanted to make sure you know about it.
Thank you.
So so you are doing you are doing this project in your spare time, not all this
Yes.
material ideas
Yeah.
development is doing in your spare time. You started this before coming here, right?
Yes. I mean, this prototype, no, but these ideas, this problem, yes.
But here you found somehow the environment to continue your project.
Yeah, I think so.
You're not, so you have time to do this, or you're overwhelmed by, I mean, you are attending courses, but still you find.
Well, it depends on the time of the semester, but now until finals are done, yes, I'm not working on it. After finals, I probably do. I would.
What is your plan? What do you want to do? Because you present your idea, what you are doing, but you are not saying. You are saying, okay, you presented the vision, the background and the vision.
Yes, I want to.
The background and the vision.
Yeah.
The implementation there is.
No. I have clear idea of implementation. I want to create a generic tree editor that would be able to edit any tree, so that on top of it, I could create or allow others or myself to create programming languages, structured programming languages that have code as tree, and do it easily.
But you showed a screenshot of something that is in my prototype, right?
This is the prototype, yes.
So this I cannot read very well, but Factorial?
Yeah, it's a Factorial. I just try to write Factorial in imaginable language that expresses tree. So that's how it would look like.
So you have some sort of prototype, or this is just made up picture? This is what I'm asking. So
No, it's a web application. It would draw it.
Okay.
So another thing that you mentioned in the presentation is time travel debugging.
Yeah.
Right. So you probably want some example, not the Factorial, to test that. Right? Is it going to be baked into your environment that you're doing? Because editing trees is one thing, but running them and being able to debug them.
The thing is, the time traveling is not the issue of the IDE, it's the issue of the programming language. Does it allow it to happen? The runtime.
Making it possible is up to the
Yes.
the language, right? But the implementation is still IDE.
Yes.
So if your IDE doesn't have capabilities to do the time traveling part,
Mhm.
or even without time traveling, just debugging or running examples, then it would be hard to edit later on. So maybe it should.
No, I don't think so. The idea is that there is a platform with API in which you could work with trees. And there would be many small programs that work with trees and maybe share trees. So it would be time traveling would be just some of the plugin that uses other plugins.
Right, but it doesn't work with the tree itself. I mean, when you use time traveling debugging,
Yeah.
your tree, your program is fixed.
Yes.
What is changing is the input data and the current state of the execution.
Yeah, but the state of the execution is also a tree. And you can navigate that.
Oh, so the runtime, the execution environment is also a tree.
Yeah, it don't have to be stored as tree, but it should provide interface as tree.
Okay, I did not get that from the presentation.
It wasn't there.
This is interesting because you're trying to back your ideas into also user experience, user interface study in psychology. So this is very interesting. So at some point, what you want to do when you propose something, I mean, a prototype, you want to do also human style problem. So this is on both sides. There is a development part, and there is also the user experience study. And so what is interesting also to create proper questionnaire for programmers or user system and so try to see how it's perceived. This is the bulletproof for your point, for your work. Do you have any questions?
It's very nice. Thank you.
Any other question?
Okay, thank you.
Thank you.